The paper of the day is Anti-Caching, a new approach to database management system architecture. This paper presented a new architecture for managing datasets that are larger than available memory while executing OLTP workloads. With anti-caching, memory is the primary storage and cold data is evicted to disk. Cold data is fetched from the disk as needed and merged with in-memory data while maintaining transactional consistency. They also presented an analysis of their anti-caching model on two popular OLTP benchmarks, namely YCSB, that stands for Yahoo Cloud Serving Benchmark, and TPCC, across a wide range of data sizes and workload parameters. On the workload and data sizes tested, their results are convincing. For skewed workloads with data 8 times the size of memory, anti-caching has an 8 times to 17 times performance advantage over a disk-based DBMS and a 2 times to 9 times performance advantage over the same disk-based system front-ended with a distributed main memory cache. Let's look at the evaluations that the paper used. To evaluate their anti-caching model, they implemented a prototype in HStore and compared its performance against MySQL, an open source disk-oriented DBMS. They tested MySQL with and without memcached as a front-end distributed cache. They used the OLTP bench framework for the MySQL experiments and HStore's built-in benchmarking framework for the anti-caching experiments. Paper used YCSB and TPCC benchmarks for their evaluations. YCSB is the Yahoo Cloud Serving Benchmark, is a collection of workloads that are representative of large-scale services created by internet-based companies. TPCC, this benchmark is the current industry standard for evaluating the performance of OLTP systems. Let's look at the contributions of the paper. Authors have implemented a prototype in the HStore DBMS and performed a thorough experimental evaluation of the three different DBMS architectures. Traditional, that is disk-based DBMS, traditional disk-based DBMS with a distributed front-end cache, MySQL plus memcached, and anti-caching in a main memory DBMS, that is HStore. The results of these experiments show that the anti-caching architecture outperforms both the traditional disk-based and hybrid architecture on popular OLTP workloads. The difference is even more pronounced at higher skew levels and demonstrate that main memory databases designed around anti-caching architecture can scale to significantly larger than available main memory while experiencing minor throughput degradation. Anti-cache design is based on two key assumptions. Foremost is that their current prototype restricts the scope of queries to fit in main memory. They do not consider this a huge hindrance since such large queries are uncommon in OLTP workloads. The other design assumption is that all indexes fit in memory. The trade-offs of using large secondary indexes is well-studied topic in database optimizations, and they do not believe that this requirement is overly restrictive. Now let's talk PS score for this paper. This paper is overall a very pleasant read, so it gets 9 out of 10 on readability. With 12 pages long, it scores 9 out of 10 on length. It's an analysis of an existing system with a new design with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is pretty high, so it gets 10 out of 10 on each, with overall PS score of 9 out of 10.